Hello and welcome to 12.4, Inverse Matrices and Systems. So we are going to be solving systems in this section, but not in a way that we've done before. This is going to be different from several units ago when we solved systems with matrices back in semester 1. So let's talk about it. So we're going to be using what's called a matrix equation. And so we're going to set up this equation, AX equals B, where A is called the coefficient matrix, X is the variable matrix, and B is the constant matrix. So for this system, A would be this matrix. It's called the coefficient matrix because you just take the coefficients of each of your variables and that becomes your matrix. So see that? How the coefficients match. So this is the coefficient matrix. The variable matrix has your variables in them, and make sure that they are in the same order top to bottom as your variables are from right to left. Okay, hopefully that makes sense. So if it's X, Y not from right to left, from left to right, sorry, from left to right. If it's X, Y from left to right, then it should be X, Y from top to bottom. So that order is important. And then this is your answer matrix, or your constant matrix. So the constants on the left. Wow, I'm really mixing up my right and left today. The right side of the equation, the constants on the right side of the equation are going to go in your constant matrix. So hopefully this kind of makes some intuitive sense. You have the coefficients. If I did matrix multiplication with these, I would get 3x plus 4y, right? And 2x minus 3y. So if I multiplied these out, I would get this. So hopefully this makes some sort of intuitive sense. And then the answer is on this side. So, okay. So if we had this where it was adding, right, we would know what to do, right? We would just subtract the matrices. When you're subtracting matrices, you just subtract each term. It's pretty straightforward, right? 5 minus 4 is 1. 3 minus 2 is 1. 6 minus 5 is 1. 10 minus 8 is 2. This variable matrix equals this. So once I get a solution, this would be my answer, right? So this is my variable matrix equals this. So depending on what this is, like if this is X and Y, my variable matrix is X and Y, then I would say, okay, then I have two solutions, 2 points, X equals 1, Y equals 1, and X equals 1, Y equals 2 would both be solutions if that's what this matrix was. This matrix might be 4 variables. It might be like an X, Y, Z, W, and then this would be X, Y, Z, W. It just depends on what this variable matrix is, okay? So that would be if I'm subtracting. So what if I'm multiplying? How do I get rid of this? Well, to get rid of this, I need to multiply it by its inverse. Because if you multiply two inverses together, you get the identity. So if you multiply something times its inverse, you get the identity matrix. And the identity matrix times X is just X, because remember the identity matrix, if you multiply it by something, it doesn't change anything. So I want to multiply by the inverse to get rid of what's on this side. So if I multiply the inverse on this side, I also have to multiply it on this side. So I'm going to multiply the inverse here. And when I do that, whatever I get is going to give me my solution. So in this one, they did that. It doesn't show what the inverse is. We'll talk about finding that in a minute. I mean, we've done it in the previous section. But if I multiply both sides by the inverse, I end up with w equals 2, negative 3. Now, assuming that w is xy, assuming that, right, then I would say that x equals 2 and y equals negative 3. All right, so let's do some actual examples. Yeah. Let's do some actual examples. So looking at this, I want to find a in this first one. So first thing I need to do is I need to get the inverse of this. And remember, our formula for the inverse of a 2 by 2 matrix was I have 1 over the determinant times, I change the positions of these two and I make these two negative. So assuming that this was originally A, B, C, D, right? I switch the position of these two and I make these two negative. So the first thing I need to do is I need to find the determinant. So I have to find the determinant of this, which is this diagonal minus this diagonal. So I have negative 11 times 0 is 0. So let me just write determinant here. 0. And then negative 3 times 1 is negative 3. So minus negative 3. So the determinant is 3. Yay. So then the inverse is going to be 1 over 3, right? 1 over the determinant. And then I'm going to switch the places of the negative 11 and the 0. And I'm going to switch the signs of the 1 and the negative 3. And then I'm going to distribute my 1/3. That's my last step. So the inverse is going to be 0, 1, negative 1/3, negative 11/3. All right, so this is my inverse. Now I need to multiply the inverse times the constant matrix. So the inverse times the constant matrix. Now remember, I have to make sure that my dimensions work out for multiplying. So this is a 2 by 1, and this is a 2 by 2. And I need those middle ones to be the same. So I have to do this one first, then this one, so that the middle ones are the same. Because if I did this one times this one, then I would have 1 and 2. Those aren't the same. So I have to do inverse times answer matrix. So I have inverse times constant matrix. Sorry, I keep calling it answer matrix. That's not accurate. It's the constant matrix. Okay, so I'm doing this multiplication and I'm going to get a 2 by 1 as my solution. That's what I want, right? Because I just want x and y. Assuming that this is x and y. I'm not actually told. All right, so let's do this. So I get 0 times negative 11 is just 0. 1 times 4 is 4. So that's my first one. And then I get negative 1/3 times negative 17 would be 17/3 plus negative 11 times, negative 11 over 3 times 4. So negative 44 over 3. And then we can simplify that. So we have 4 on top. Sorry, things are kind of running together. We have 4 on top, and so 17 minus 44 is negative 27. So negative 27 over 3. Negative 27 over 3 is negative 9. And you can do that in a calculator or in your head or however that works for you. Okay, so this is my solution. This would be my solution. You could have a situation where you don't get a solution. Maybe you can't multiply because the dimensions aren't right or something like that. Then you wouldn't have a solution. Where you end up something like, I don't know, something else that just doesn't work. Then you would have no solution. But I think generally, if you can't multiply, right? If you physically can't do the multiplication, then obviously they're not going to be a solution. So let's go ahead and do the second one. So I'm going to erase all of this. I know this video is going to get a little long. After this one, I will stop the video and have the next examples in the next video because this is getting long. Okay. So first thing I need to do again is I need to find the inverse of this. So I'm going to find the determinant first. So the determinant I'm going to write over here. Remember, we're doing this problem, but I'm going to write over here for the sake of space. So the determinant is going to be negative 1 times 6 is negative 6 minus negative 2 times negative 1, so minus 2, right? Negative 2 times negative 1 is positive 2, and then I'm subtracting. So negative 2 equals negative 8. So that's my determinant. So I have 1 over negative 8 times, I'm going to switch the locations of the negative 1 and the 6. So I get 6 and negative 1, change the signs of the negative 2 and the negative 1, so 2 and 1, and that is my inverse. No, I have to distribute the negative 8. Not quite done. I distribute the negative 8. So I have negative 8, 6 times 1 over negative 8 is 3 over negative 4. 1 times 1 over negative 8 is 1 over negative 8. 2 times 1 over negative 8 is 1 over negative 4. Negative 1 times 1 over negative 8 is positive 1 over 8. So this is my inverse. So I'm going to multiply this times this. So this is an interesting case because for the dimensions to work out, since the dimensions are the same, I don't have a restriction on whether I do this one first and then this one, or this one first and then this one. I could do it either way. So let's do it both ways and see what happens. So I'm going to start way over here because I know I'm going to run out of space. I'm multiplying this by 2, 9, negative 28, 34. All right, I'm going to erase this because I just need the room. Sorry, I confused it. Okay. So I'm going to do that multiplication. So I'm going to do this on the calculator so it goes faster. So I'm not going to be saying everything that I'm doing here. I'm just going to sort of do it. So give me a second. All right, so if we have 3 over negative a fourth times 2 plus 1 over negative 8 times negative 28, that's going to be 4 over 2 if you do that math. And then if I have 3 over negative 4 times 9 plus 1 over negative 8 times 43, I'm going to get negative 11. And then negative 1/4 times 2 plus 1 over 8 times negative 28 gives me 6 over 2. And then 1 over negative 4 times 9 plus 1 over 8 times 34 gives me 2. So this is my first solution. So let's look at what happens if I switch the order that I'm multiplying these in. So for the sake of space, I'm going to write my one solution that I just got over here. And then I'm going to erase what I have down there and start over. So I'm going to have, I don't actually want to erase my inverse before I rewrite it because I don't have it written anywhere else. Negative 4, 1 over negative 8, 1 over negative 4, 1 over 8. Okay. And then I'm going to have the other one on this side. So 2, 9, 28, negative 28, 34. So I'm just changing the order in which I'm multiplying them. And then we'll see what happens if we get a different answer. So this is also going to play into that unique solution thing. So we very well might have two different solutions. So in that case, there would be no unique solution, but we would in fact have solutions. They just wouldn't be unique. So let's look at this. So if I have 2 times 3 over negative 4 plus 9 times 1 over negative 4, I'm going to get negative 15 over 4. So already this is different than the solution we got last time. And then if I have 2 times 1 over negative 8 plus 9 times 1 over 8, I'm going to get 7 over 8. And then if I have negative 28 times 1 over negative 4, nope, that's not how this works. Negative 28 times 3 over negative 4 plus 34 times 1 over negative 4 is 25 over 2. And then negative 28 times 1 over negative 8 plus 34 times 1 over 8 is 31 over 4. So this is my other solution. So I have two solutions. I have this one, which I forgot to put brackets around, and I have this one. So this one, I would say there's no unique solution. There are two different solutions. There's two possibilities for what y could equal. So y either equals this or it equals this. We don't know which. Maybe it's both. Maybe it's like quadratic where you have two solutions. So there's no unique solution, but we do have two workable solutions. So that's interesting. And in this case, you would have to do it both ways before you would know, because there are some rare cases where you can do it both ways and you actually will get the same solution. But again, if you have a situation like this where the multiplication only works in one direction, then that's fine. And you do, in fact, have a unique solution, and you know that from the beginning. It's only in the situation where multiplication is doable both ways that you have this problem. All right, so hopefully that helps. And let me know if you have any questions, and I will see you in the next video for some more examples.